Alright guys, now we're going to start talking about some volume here. This is 11.5 volumes of prisms and cylinders. So volume of a prism is V equals base times height, where big B is the area of the base. So prisms are just any shape we talked about in the last part of this chapter that adds dimension to it. So see how this is a square and it has dimension to it. It gives it height. You could also see it in some of these pictures where it's at an angle, or it could also go backwards theoretically towards the paper. But really, big B is the area of the base, H is the height. So find the volume of this would be a rectangular prism. The big B in this circumstance would be 24 times 20 because that is the theoretical base of this shape. So 24 times 20, that is big B, and then the height is 10. So 24 times 20 is 480 times the height, which is 10, puts us at 4,800 centimeters. And now that we're talking about volume, all of our volume will be cubed. Still a rectangular prism, and we're still working with big B times the height. Big B, the base of this thing, is a rectangle, so 10 times 4, which is the base, times 12, which is the height. 10 times 4 is 40, times 12. 12 times 40 is 480. And like I talked about just before, all volume will be units cubed. 3 through 6 says find the volume of the blank prism. These are all triangular prisms. Still be the same formula that we had before, big B times H. So big B times H. Big B in this circumstance is the triangle. So triangle's formula is 1/2 base times height. And all that refers to is the triangle. And then the physical height of the shape would be 7. So 6 times 8 is 48. So I have 48 divided by 2 times 7. 48 over 2 is 24. 24 times 7 is 168 centimeters cubed. Next shape, although the right angle isn't up here, it is vaguely put down here, which allows us to know that those are the height and base of this triangle. So once again, it's still big B, which is 1/2 the base and the height of the triangle. So 3 times 4 times the height of the shape, which is 2. So 3 times 4 is 12. I'm cutting that in half, and I'm multiplying that by 2. Half of 12 is 6, times 2 is 12. And we are centimeters cubed here. This triangle at an angle, but once again, all we need to recognize is the base shape, which is a triangle, and then the height. So big B times the height, so 1/2 base times height, 9 times 5, times the height of the actual figure, which is 8. 9 times 5 is 45. So 45 halves times 8. 45 halves is 22.5 times 8, which is 180. 22.5, not 22.2. So it's 180 meters cubed. Here, another triangle. This one has the one that I talked about, how it kind of goes back towards the paper with the thing that gives it depth. There's 2 triangles that are the same shape that are stacked on top of each other, 5 centimeters high. So we're still working with big B times H. Big B is this triangle down here. So 1/2 the base, which is 3, times the height, which is 1.5, times the physical height of the prism, which is 5. So 3 times 1.5 is 4.5 over 2 times 5. Half of 4.5 is 2 1/4 times 5. 2 1/4 times 5 is 11 1/4 centimeters cubed. Down here, this is what would be called a trapezoidal prism. Where we get that from is base 2 shapes are trapezoids. So we're still working with the same formula, big B times the h, so 1/2 base 1, which is 14, plus base 2, which is 6, times the height of the trapezoid, which is 3, times the height of the prism, which is 5. 14 plus 6 is 20, and we're taking half of that times 3, times 5. 20 divided by 2 is 10, times 3, times 5. 3 times 10 is 30, times 5 is 150. 150 centimeters cubed. And that would be the volume of all these prisms. On the back side, what we talk about is volumes of cylinders. So the cylinder formula is still big B times h, where B is the area of the circle, or area of the base, and h is the height still. So just like we had on the back side, and r is the radius of the base circle. So it's still the same formula. We're still stacking stuff on top of each other. That's what makes it a prism, essentially. So the radius on this one for number 8 is pi r squared times the height. So pi, my radius is 2, so 2 squared times the height, which is 3. Once again, this is still just big B times h. 2 squared is 4, so I have 4 pi times 3, which is 12 pi inches cubed. Here, number 9, my diameter is 18, which means my radius is going to go ahead and be 9. So big B times h, so pi 9 squared times the height, which is 24. 9 squared is 81 times pi times 24, and then 81 times 24 is 1944. Don't forget about the pi, and these ones don't specify units, so we're just going to go ahead and throw on u cubed at the end for units cubed. Down here, number 10, the radius once again is 9, so we're taking big B times the h, so pi 9 squared times 6 puts us at 81 pi again times 6. 81 times 6 puts us at 486 pi. This one does specify units, so we're going to go feet cubed. This one is half of a cylinder, so you have a semicircle up top, a semicircle down bottom. So all that really means is we're going to do everything we did up at the top before, but we're just going to cut that number in half. So we have pi r squared, the radius. If this distance is 4, half of that would be 2. So 2 squared times the height, which is 15. But in the end, we're going to cut this in half because, like I mentioned, it is half a cylinder. So 2 squared is 4 pi times 15, if we cut that in half. So 4 times 15 divided by 2, half of 4 is 2, so 2 times 15 is 30 pi centimeters cubed. Working backwards, so they tell us the volume of this chest to be 72 cubic feet. You want the length to be 6 feet and the width to be 4 feet. What should the height be? So volume is equal to big B times the height. We're looking for the height. So volume, like they mentioned, is 72. Big B is 4 times 6, because that is the base shape, and we're looking for the height. So 72 equals 4 times 6, which is 24, times h. Working backwards, doing inverse operations, that tells us the height should be 3, and we are in feet. This one's just a linear distance, so we're just going to go ahead and leave it as feet, not feet squared or anything like that. These are composite solids. It's kind of hard to see, but this is a cinder block. So I have 2 shapes, well, theoretically 3 shapes in this problem. So I'm going to find the area of the rectangular prism. So I'm going to call area of RP. And then I'm going to subtract the area of the smaller rectangular prisms, because essentially we have 2 cutout rectangular prisms there. The entire rectangular prism is found from 1.31 times 0.66 times 0.66. So this is big B, this is h. So 1.31 times 0.66 times 0.66 puts us at 0.571. And that would be that would be the volume of the entire cinder block. Then I have two shapes that are cut out that have a base of 0.39 times 0.33, and that's going to be multiplied by the height, which is still 0.66. And I do have two of those. So I'm going to take 2 times 0.39 times 0.33 times 0.66. I'm going to get minus 0.169. Oops, 69. So if I take 0.571, and I'm doing rounded to the nearest thousandth on this, just to simplify it a little bit, since I don't specify on this particular problem, you could round to whatever you would like. But since I rounded to the nearest thousandth, I'm going to have a volume of 0.042 feet cubed. This one is more of like a triangular cinder block, but this is a triangular prism and a rectangular prism N1. So if you can't see, this is an equilateral triangle, so that this is 10, this is 10, this is 10. So I have to find the actual height of this prism to do the area of the triangle, the area of the base. So if this is 10 and I cut that in half, that means this is 5. If we remember, these are 30, 60, 90 triangles, which makes that 5 square root of 3, which makes the height of this triangle 5 square root of 3. So I have 1/2 base, which is 10, height, which is 5 square root of 3, and that takes care of big B, times the physical height of the prism, which is 6. So I have 1/2 times 10 times 5 times 6, which means I have 150 square root of 3 for the entire volume. But now I need to remove that rectangular prism. If you can see, they have that arrow there pointing that it's a 3 by 3 square, so 3 times 3 is the base, times the height, which is 6. So 3 times 3 is 9. So I'm subtracting 54, and this is just going to be my answer, so feet cubed, because remember, we cannot add and subtract things that don't have like terms. So there's the notes. Take care of the homework. See you guys on Monday.